Okay, so this is Soko James, and I'll be doing question 3B. So unfortunately, this was supposed to be done by Bwalya, but the question at Samuela, so I'll just do it today because the submission is tomorrow. Okay, so we won't waste much of the time. I'm going direct to the point. So let me read out the question first. So the question says, the network design shown below needs to be configured with OSPF. The two servers are file servers belonging to marketing departments. You are required to create a file that will allow only inside networks to access the servers and block outside traffic from accessing the file servers. The IP address is this, which is a class A. So we won't waste much of the time of subnetting, so just use a subnet calculator, which is this particular site which you are seeing. So you explain what's happening. Okay, so let me drag the devices as shown below, then I'll just pause the video because I want to be fast for this particular video. Okay, so now the issue with this question is that we have this subnet, or we have this switch which is belonging to subnet A, and it's connecting all these routers. Now when you are configuring OSPF, basically what we do is that we need to consider the networks for each particular device. For example, since this router is connected to this network, so it knows about this network, but here it's connected to the switch, not the router, meaning we cannot say that this particular device has a particular network for this device. So this brings about some issues because we cannot configure this switch with OSPF, but it just connects these devices. So we need to get rid of this switch, then just leave out the routers. So this is the first thing we are going to do, then I'll explain another method. So let me just remove the switch, maybe to make sense once I start working on it. So let's assume the question is like this. So we just need to make the connections now for us to start. So I'll concentrate on the routers. So since these routers are the same, we'll use this cable, same devices. So I'll say first 0, then first 0/0 like that. Then for this one, I'll go for /1. Okay, let me just do this. I won't go for /1 for this one. Let me just increase the interface. So let's increase the interface. So the interface, let's assume we want to increase the interface. I'll do this. I'll increase the interface the way I want them, and then say on. Okay, then let me also increase the interface for this router. Under physical, we switch off the router, and then we drag these Ethernet ports like that. So on. Then now I can go back to say, let me connect this device maybe at /6, then this one again at /6 to make them unique. So since OSPF stands for Open Shortest Path First, we need to have at least 2 or more links which are paths or routes to take. So due to that reason, I'll put another route to take, so on this particular device. So what I'll do, I'll need to increase the interface for this particular device. Okay, So I'll increase the interface again. Oh, by the way, this router is 1841, so let me just use a PT router. So sorry. So I'll use a PT router because I'm just using PT router, not the ones which were given. I just need to increase the interface. So under physical, switch it off, then drag these ports to increase the interface. So on. So after we do that, we can now connect our things. So for this one, I had connected on 0/0, so I'll just do that. Then the link I was talking about, maybe I'll just say 7/7 like this. Okay, now makes sense. So after doing that, I'll just pause the video to make the list of the connections. Okay, before I do that, I'll be connecting a router to the switch at 1/0 so that we all know the ports we are dealing with. So it's 1/0. Even there, I'll just do the same, which is connecting to the cloud. I'll say 1/0. And then I'll use Ethernet 6. So take note. Okay. So after we do that, now I can pause the video. Okay. So now our job is to make sure that we configure these things with IP addresses. So yeah, you can just go, you use this site, which is Subnet Calculator, if you want to be fast, because I don't want Subnet class E. Okay, so we are using a /11. So we are using a /11, and you can see /11. So we are using a /11 to come up with this number of networks. So imagine this is the first subnet. So I would copy this, then I will represent this as the first subnet, like that. So I'll say if this is the second subnet, I will represent it on this network as the second subnet. Then this is the third subnet, I will represent it on here. Then let me just pause the video so that I put things smooth. Okay, so let's imagine this network belongs to that network, this network to this network, then this network to this network. Now, since these two routers connecting at FA0/0 must be another network, so I'll get another subnet to represent that particular network. So I'll say, okay, this network must be for this network. Then I'll get another network to represent this network. The last three, I'll get another network to belong to this network, like that. Okay. So let me just explain. So based on the question, what we were saying is we have subnet A. So imagine this is subnet A. We'll say subnet A. Imagine that subnet A. Then we are saying we have subnet B. So we are saying this is subnet B. Then last we have subnet C. So we are saying this is subnet C. So no wonder I've indicated these three networks with different subnets. Okay, but again, we need another network for the routers, which is this. Then we need another network for these two routers, which is this and these ones. No wonder we have now multiple different networks. Now, based on this, we can start off answering the question. Okay, so let's start with subnet A. Now, for subnet A, this is the default gateway, because this is the network. So I'll get this now. Since we have used /11, it means the mask is 224. So as you can see, the mask, since it's a /11, where is our mask? Yeah, like this. So we have a 224 here. So that's the meaning. Okay, so this default gateway will be inserted on this particular interface connecting to the subnet A. So this interface is FA1/0 from the router. So I'll make sure that that interface is up. So here, remember, we have 224, then I just need to say on, like this. So that interface is up. So I target now subnet B. So for subnet B, this is the default gateway. So I'll make sure that this interface is up. Okay. So which is connecting to subnet B. So again, it's 1/0. First Ethernet 1/0. Then here we say 224. We say on. Okay. Then now, remember we have devices here. So I would like to configure the server. So I'll go under the server, desktop, IP configuration, then I'll say .2. Then remember this is 224. Then the default gateway is .1, like that. So that is configured. Go to the PC 0. So for the PC, let's just give it .3. And then here it's 224. And then the default gateway, like that. Okay, we are done. We got subnet C. So for subnet C, this is the default gateway. So it will be inserted here now, which is 1/0 again from the router. So we go at this interface, we make sure that it's 224, and then we say on, like that. So now we configure these devices. We start with the server. So same procedure. So we say .2, and then remember it's 224, and then .1, like that. So PC, and now we do it to the PC. So for the PC, now we say .3, and then here we just leave it at 224, then .1, like that. Okay, so everything is neat. We are done configuring the networks. Now we go to the routers. So between this and this, we have this network, and this is the default gateway, but we don't say the default gateway for the routers. We start assigning. So I would like to assign at F0/0 for this one. So here I would say this is the network on. And then now, since we have used 1 for that particular device, this would be 2, and then on. As you can see, the interface now is up. So now we use this information for this particular interface, which is 0/7/0. So I would get this, and then I'll insert it here where we have 7, and then I'll say on, and then I'll go where there's 7 for this router, and then we say 2, and I'll say on. The interface is up. Then now we have this network, so get this IP, then the connection is at 6/0. So I'll go at 6/0, then we'll say okay, 1 is just okay, then on, and then we finish it up here where there is another 6. We say 2, then on. Okay, everything is okay. We get rid of those port numbers now, so that at least we see it clearly. So this is our topology now, guys. So we are good to go. The first thing we'd like to do is to go under simulation mode. Then under simulation mode, what we'll do, we'll try to check if a packet can go maybe from this to this guy, which is the first thing we can try to do. Okay, so let's see. So as you can see, this packet has been delivered, so it's okay, we've configured, okay, which is correct. So it means even this connection here, it's correct. Now for this one, we don't have a device. So for us to make sure that we work on something, I would simply maybe just put a modem. So I would put a cable modem here and then a device. Okay, so let's also put a PC to represent this network. So now the connection we'll be using is coaxial from the cloud to the modem, then from the modem to the PC is Ethernet. So let's just configure this PC with an IP address so that we see what we're trying to do. So in this case, since this was the default gateway, would assign this PC with .2. So say .2. Here we have a 224 because it's static, wonder it's not changing. And then like that. Okay, so if I go back in real time, then I say, okay, so if this particular device was trying to communicate with this device, so this device is .3, 10.32.0.33. So I'll try if the server can communicate with the nearby PC by saying ping 10.32.0.3. So as you can see, this server can communicate with this PC. But again, what if we say, can we communicate with this particular guy or this guy or any other guys? So in this case, we would check the IP address for this one. So okay, so it's 10.0.0.2. So say we have a 2 here, and then we have a 0 here. So this is the IP address for this PC. So if we check, it's saying destination host unreachable because there is no routing information protocol such as OSPF to enable communication. So same applies if we try to ping this other device from here, which is 10.64.0.3. So let me just do that. So we are saying 64 here, and then we have a 3 here. So this is the IP address for this guy. So again, we cannot communicate because we don't have OSPF or any other routing protocol enabled yet. So now this takes us to OSPF. So the question was saying we need to configure OSPF. So let's talk about OSPF now. So OSPF stands for Open Shortest Path First. So let me say if this device wants to communicate with this device, instead of taking the longer route, which is this, to communicate with this device, it will take a shorter path, which is this, to communicate. So that's OSPF. Now OSPF is configured in a router. So let me say here we are targeting router 3. So since this is our router 3, so if we are targeting router 3 in the router under command line interface, we say n conft. Okay, now since we are putting router, we say router OSPF, then we give it a number such as 1. Then we broadcast the networks we know. So in this case, router 3 knows about this network, which is 10.32.0.0. So say 10.32.0.0. Then the broadcast bit, since this is /11, which is 224, so the block size is 32. So if you want to confirm, you can simply do this. Okay, so let me open up my calculator. Since it's a 2224, we'll say 256 minus 2224. You can see this is the block size, which is 32. So the broadcast bit, to just remove a 1, we'll say instead of 32, we'll say 31. 0.0.0.31. Then we put it in area 0. So I'll copy this network. Now again, router 3 knows about this network, which is 96. So we'll say that then here we'll put a 96. Then I won't change the broadcast bit because we're using static. Then now router 3 also knows about this network, which is a 1 skist. So we'll put a 1 skist there. The broadcast bit remain the same. Then we end the commands and WR. So these are the commands which can be inserted into router 3 for OSPF. So I'll go into router 3 under command line interface, exit this mode, that mode, then I just paste the commands for in router OSPF. So we are done. Now we also do the same for router 2 and 1. So here I'll go, this is for router 2 and this will be for router 1. Then we'll just start modifying. Okay, don't want to waste much of our time. So this is router 2 and this is router 1. Okay, so router 2 is connected to this subnet, which is 3 zeros. So you put 3 zeros, that's the first network. Then again it's connected to this network, which has a 96. You leave it the way it is. Then the last network, it's 128. So we just need to put a 128. Then we are done. Simple. So we copy these commands, we paste them into router 2 under command line interface. I'm way faster because my PC can shut down any minute from now. We don't have power. So I'll paste and then we do that. Okay, then router 1. So this is router 1, as you can see. So router 1 is connected to this network which has 64. So put a 64 where there's 32. Then again it's connected to this network which has 1 skist. So 1 skist is just okay. And then this network which has 128. So change the 96 to 128. And then everything is cool. We are done. So just paste the commands into router 1, command line interface, exit, exit, then exit. Okay, then we paste. Okay, so now we can try out OSPF. So I was saying, if this network wants to communicate to this guy, the shortest route to take is this one, not the other way around. So let's see how the packets move. So we've configured OSPF. If no error was encountered, it means everything is okay. Then we'll try to see using that ping command if now we can communicate with that particular target we are trying to communicate to. So that's the whole point for this particular configuration. So now let's check the packet. So now it's moving, it needs to reach this destination, then supposed to go down, which is here. Okay, then it will come here, then here now. So it means we have reached our destination. Okay, so here to tick because that's our destination. So since this is our destination, it means OSPF has been configured, so that if we go back to see if we can communicate with those particular devices wanted to see if we can communicate to, now it work out, as you can see, because OSPF has been configured. So now why aren't we communicating with this particular device, which is this over the network? Is because we haven't configured the crowd yet. So under the crowd, since we're using coaxial 7, we'll just go under Ethernet 6, the one we've used to connect. So Ethernet 6, we are using cable, so I'll say cable because it's a cable modem. Then under cable, we have coaxial 7 and Ethernet 6. We just add it, then we are good to go. So that if you go back to ping that network, you realize that, okay, now it's to start working. So let's see again. So now we've configured the crowd. So if we see, now we can communicate, which is good. Okay, now let's follow the question once more, and then we are done. So the question was saying the two servers are file servers belonging to marketing departments. You are required to create a file that will allow you only the inside network to access the servers and block all outside traffic from accessing the server. So let's assume this PC, since it's in the same network, which is Subnet B, with this server, it's allowed to access this particular server. But this device is not supposed to access this server because it's not in the same network. So we'll make sure that this device doesn't access this server. So what we can do is just find out the network for this particular PC, the IP address, so it's 10.32.0.3. So first of all, before we even proceed, we'll do this. The IP address for the server, it's 10.64.0.2. So we'll say, let this PC ping that server, ping 10.64.0.2. I'm sure it's .2. Let me confirm if I've made a mistake. Okay, so it's .2. Okay, so as you can see, this device is able to ping with that particular server, but since this device is not from this subnet, we don't want it to be possible. So I just need to know the IP address for this PC, which is 10.32.0.3. So I'll go into this server, then firewall. Now here the action will say deny, because we don't want traffic from that particular IP, which is 10.32.0.3 to enter that particular server, or to ping that this particular server. So the protocol we are blocking is IP for internet protocol, because so far we have configured an IP protocol, which is OSPF. Then the broadcast bit is 0.0.0.31, since the block size was 32. We make sure that the service is on, then we say add, then we just save this particular configuration. So if we go back to this PC, if we can access that server, ping that server, now it needs to refuse that, because now the server has blocked that outside traffic from entering the internal traffic. That's the meaning. So I'll say Ctrl+C to cancel. Okay, so we've applied it here, yes. Now let's also do the same. Since this PC can ping that server, let me check the IP address for the server, 10.32.0.2. So I'll say ping 10.32.0.2. So as we can see, this device can communicate with a server which is not from its subnet. So we need to block this particular device from doing that. So the IP address for this device is 10.64.0.3. So under the server, we'll say firewall, and then the IP address is 10.64 .0.3, then action is denied because we don't want to allow any traffic. Then I explained we're blocking IP, so the broadcast bit was this, and then we just need to add, then we save, then the service must be on. So if we try to ping again, if we can access that server from the outside or external network, you won't be able to ping with that particular device, which is good. So Control C to cancel. Now this device should not access either of these servers. So what we need to do is to know the IP address for this particular guy. So in this case, okay, before we do that, let's see if it can communicate. So this server is 10.32.0.2. So we'll start off by pinging this server, which is 10.32.0.2. So let's see if we can communicate. Let's see. Let me confirm the IP address. 10.32.0.2, which is that. Okay. So okay, let me also confirm the IP address for this one. Okay, so it has a 64. Okay, so this device is not able to ping. Maybe let me check the configurations. I see what went wrong. Yeah, let's check under simulation mode. So under simulation, let's see if we can communicate with that guy. So we see if this server can communicate with this guy. Okay, so by the way, the question is done because this network has just been created by me. The question ends to the crowd. So the video is done. We are just trying to see how we can expand our knowledge on this particular question. So we can see we are able to communicate, but I'm sure the issue is with this device to communicate to these other devices. Maybe when configuring I left out something, but my PC is just down. It can shut down any minute from now. So if I won't be able to analyze the so the PC was off, as I was saying, so which is bad. So due to this, I'll just save this project. As you can see, my PC was off, but forget about this part. Maybe I'll do it later on, but the question is done. Oh, the second thing we're supposed to do is to, instead of using that switch we are given, we can just put a layer 3 switch here, then configure it with everything. So just request for these particular two solutions which has no switch and the other one which has layer 3 switch. I will just send it to you. So this marks the end of the video. My name is Soko James, representing KMU Cybersecurity Tutorials. Wishing you the best in the submission of your assignment. and I hope this was helpful. Thank you.